Alright, so guys, as we're looking at today's lesson, we're looking at a lot of different aspects of this. We're looking at some different types of reactions, some of the definitions you guys will need to know. We're looking at acids and some bases. And so if we're talking about acids, it might be a good time to kind of review what the pH scale is. And so as you guys can see up here, by the definition, all pH is the degree of its acidity. So what do you guys know about pH? I guess let me just throw that out there right now. What do you guys know about pH? I mean, it's a sound. No, that's a diphthong going. That's not about that. Below what? Anything below 5 is acidic. Yeah, oranges are acids, citric acid. Okay, good. Hey, rest of the group, what do we know about pH? What do you guys know? It's made up of acids and bases. All right, it's a scale. Do we know what the scale is? What's the range of values for the scale? No. No, no negatives. No, there's no negatives. 0 to 14. Okay, so on what side are my acids? Are they at the 0 or are they at the 14?
0.
They're at the 0. Where are my bases at?
14.
14. Okay, so the acids and bases are opposites of each other. Right? Okay, where's water?
In the middle. No, at 0.
Water's in the
No, like 14.
So water's the base?
Okay.
Well, then it won't be pure water. Where would we find pure natural water?
In the ocean.
No. Alright, so here we go. Notice that water is at 7. Your acids are at 0. Your bases are at 14. And a couple of terms I want you guys to know. So we do have acids way down here at the 0 level. And we have bases way over here. A couple things you probably didn't know. So water is neutral at 7, right in the middle. Did you know that milk is slightly acidic? Yeah, just slightly. It's at a 6. Tomato juice are 4. They're halfway between the 0 and water. Didn't realize that tomatoes were that acidic. And lemon juice, you know that really bitter, sour taste? That's an acid. In fact, it's one of the ways that we can identify acids is by their taste. And acids tend to be very sour. Bases tend to be very bitter. And so it's one of the ways you can tell them by their taste. Now, I don't suggest you go around drinking all types of liquids to figure out which one it is. We do have other ways of measuring this. Typically, if you want to measure the pH of something, there's a little strip that you can buy, pH test. And all you got to do is just a little strip on the liquid or material, and it'll come back out with a reading for you. And all you got to do is match up the color. That's usually how we measure pH. Now, we do have some more advanced tools now where we're starting to do this digitally. We can take a probe and drop it down into the liquid, and it'll spit back out the pH for you. So, kind of avoids the whole strip thing. The strips are a lot cheaper. Some of the other things I want to point out to you guys here is all of our acids are going to be on this side, and all of our bases are over here. But what do you notice that's over here?
Drain.
So we got drain cleaner, we got household ammonia. Yeah, bleach is also going to be a base. So almost all of our normal cleaners are bases. I'm not sure if you guys were aware of that. Drain cleaner, we just put that up there. So like glass cleaner or your all-purpose spray, those are going to be bases. So a lot of your bases are typically your household cleaners. What happens if I take tomato and I mix it with something that has a pH of 10? What does it do? It definitely will. It might bubble. It won't explode. What would happen to it? Okay, let me put it this way. Let's let's say that I spill, I don't know, let's say my cat decides to urinate on my carpet. And the wife gets to it before I will, because otherwise it'd be a 25-cent problem fixer right there. Alright, so the cat pees on the carpet. What chemical is urine? Ammonia. And it smells bad, right? Alright, so that's all the way over here at 11. So my little cat peed on my carpet. Now I've got a base level of 11. That's a nasty smell. I want to get the stupid smell on my carpet. Well, what could I use that would negate the presence of ammonia? Why lemon juice?
Because it's on the other side of the
Yeah. If you think about the distance away, so 11 is 1, 2, 3, 4 units away. So if I find an acid as an additional, that's the same distance, it neutralizes that effect. Now, it doesn't mean I get water as a result. What it means is my pH is completely neutralized. And that gets rid of the smell, it gets rid of the stain, so it kind of helps out those types of things. So, also consider for pH. Now, a couple of things about acids I want you guys to know. So we have bases, we have acids. What I want you guys to know is I want you to know what these things are in terms of their chemistry. Not just the pH, I want you to know the chemistry thing. Yep, I know, me too. So, when we think about bases, yes, their pH is above 7. They have a pH scale of greater than 7. Right, Logan? But what I want you guys to know is that in their compound, they contain OH negative. That's called a hydroxide compound. So you guys remember right before break, before our 5 days off from seeing each other. Feels like all we've done has been on break. We played around with sodium hydroxide, right? We stirred it in with and it got really hot. You guys remember that stuff, the little pellets? Good. That's sodium hydroxide. That's NaOH. And when I dissolved it in the water, what happened is the sodium and the hydroxide ion got separated. And now what I have is this creates a basic solution. Not a basic as in like simple, but basic as in the pH. So if we were to take a pH strip and measure the pH after we dissolve that sodium hydroxide, we would see that the pH would be somewhere between 8 and 14. Right? And that's because of the presence of the hydroxide ion. That's what I want you guys to know. Bases have hydroxide, the OH. Now, acids, on the other hand, don't have an OH. They have an extra hydrogen ion. Okay, so these are going to have pH that are less than 7, and they contain an H+. So, for example, I might get HCO3. What type of acid do you think that would be? I guarantee you some of you guys have already drank a lot of this today.
No.
Wrong type of acid. No, that's caffeine.
Juice.
No.
Carbonic acid. CO3, you guys, is a really important compound for this class. It's called carbonate. CO3 is carbonate. So you take CO3 with the attached hydrogen ion, this little guy right here, that gives us carbonic acid. What type of beverages have carbonic acid? Soda. Okay, soft drinks. So anytime we have an H that's involved, guys, it's going to be an acid. For example, another one that's really important acid for this class that we use quite a bit, we often would use HCl. What is that? Hydrochloric acid, or we use that a lot. In fact, one of the reactions that we could do later on in this course, so we're going to take hydrochloric acid, when I put it on limestone, the limestone instantly reacts with the hydrochloric acid. No other rock does that except for limestone. It's pretty sweet. Alright, and let's continue talking here. What's the difference between a solution and a mixture? I want you guys to give me an example. Put it in simple terms. What's the difference between a solution and a mixture?